Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we will learn about recursion. Recursion is for representing iterative process, and we have example which is factorial problem. The learning objective of this video are that the student know iterative operation using recursion, and then student know the process execution of the recursion. Now we start with what is recursion. Recursion is iterative operation, so this is the key, which is done by calling a function inside of the function itself. So function calling itself. Therefore, rather than using for, while, do while for implementing the iteration, programmer can use recursion. Now the question is that, can recursion replace for, while, or do while? The answer is that if the repetition can be implemented by using for, while, or do while, it is better to use them rather than recursion. And recursion is used for specific problems only. These problems are easier to implement by using recursion rather than iterative command like for, while, and do while. For example, to represent Fibonacci series, it is better to use recursion. Or if we have to sort and we use merge sort algorithm, then it is better to represent by using recursion. Quick sort also, and then Pascal triangle, tree data structure, and so on. So now we will see an example that it will give you the comparison between for and recursion. So I have two programs, and then the first program, this one is the implementation of factorial by using for, and the second program is the implementation of factorial by using recursive. So let us see here that we have the iterative process. It is coming from this for, and here we don't have any iterative process. As you can see, we don't have any for, while, or do while. However, we have a function factorial, and what is this function? It is a function which inside of the program or this function will call itself. So there is a function called to itself. So this will make a loop. So how does recursive work? So let us see here. We will try to see one by one, line by line. So here the program execution will allocate a memory with the name of n, and the value is 5, and then we do the cout. However, in the cout we have to execute this function call. So we will go to this function call. The program execution will jump to this function, and then inside of that function we will have a variable with the name of n, and this is the input variable, and it will be the copy of here, so it will be 5. So this one is the first function call. And then what will happen? If n is less than or equal to 0, then return 1. So this is false because this is 5. And then else if n equal to 1, then return 1. This is also false. So we will go to this else. This else means that we will return a value to this factorial function and multiply by factorial n minus 1. So I have a memory. This is for the return value. The name is factorial, but I will make it short, so it will be f like this. And what is inside of this f? This is n multiplied by factorial n minus 1. So what is factorial minus 1? Factorial minus 1 means that I will call this function again, and everything will be a new function call. So it means that I will have another n variable, and I will have the return value of the f. So what is n? N is 5 minus 1, so this is 4. This is the second function call. And then what inside of the function call, that n less than or equal to 0? No, because this is 4. Equal to 1? Also no. So we go to the else. So it will return the value to the f, and the return value is just the same, which is n multiplied by factorial n minus 1. So what is n? We have the n, but this factorial n minus 1, we don't know the value, except we will do the function call first. So we will do the function call. So I will have a new function call, and I will have new variable of n, which the value is n minus 1. So 4 minus 1 will be 3. And I will have the return value of the function call. This is the third function call. And then what will happen to the third function call? That n is less than or equal to 0. No, because this is 3. This is false. N equal to 1. This is also false. So it will go to the else. Again, it will do another function call. So this will be n, which is n minus 1, 3 minus 1, so it is 2. Then I will have the return value of the f. Again, because this is 2 is not less than or equal to 0, then n is also not equal to 1. So it will go to here, to the else condition, and it will do the function call again. With the n is 2 minus 1, which is 1. And then we have the return value. Okay, so now what will happen when I have n equal to 1? So here n less than or equal to 0. No, this is not true. And then else if n equal to 1. N equal to 1. This is true, right? So this is correct. Now what will happen? It will return 1 to this function factorial. So this factorial will have 1 for the return value. So as you know that after function returning value, then it will finish. So the program of execution of the function call will finish. So it will go to here, and the function call will be stopped. Therefore, the value of this function call is 1, right? So this will be give to the next I mean the parent of the function call. So this is fourth, and this is fifth. This fifth function call is coming from the fourth function call. So this 1 will be put in here, that is 1 multiplied by 2, right? Because this return value is 2 multiplied by factorial n minus 1, which is factorial 1, and we know the value of the factorial 1 from this returning value, so we have 1 here, and this 2 is coming from this n. Okay, now 2 multiplied by 1 will be inserted to this returning value of the fourth function call. Then this returning value will be calculated in the third function call, and after the fourth function call is finished, then everything will be deleted, so the variable will not be used anymore, so it will be deleted, and then the return value will be calculated with the n, so 3 multiplied by 2, so this will be 6, and 6 will be the return value of the third function call, so this will be 6, right? And then because it's already returning a value for the third function call, then it will be destroyed, and the returning value will be calculated in the second function call, which is 4 multiplied by 6, so we have 24. This is 24. Okay, this is also returning a value for the second function call, so this already finished. Then this 24 will be calculated to this first function call, which is 24 multiplied by 5, so we have 120. This is 120, and this 120 return to the main program, which is this factorial n, and this function call is finished, so it will be destroyed. So in the main program we will have cout 120. So this is how recursive works. Okay, now we go back to the previous slide. As you can see that in for command we have the initial status of the counter, and then what is the condition, and the increment of the counter. So we have 3 parameters here, and if we want to convert this for into a recursion, it will be in the same logic. It means that we should have the initial condition. When we are doing loop, when we are doing recursion, we have to have this. What is the initial condition? And then what is the true condition to do the iterative command or iterative process? What is the condition? And then when it will stop. So this is also to defining when the recursion will stop. If you see in this recursion, then what is the initial? The initial is n equal to 5. So we will start from n equal to 5. And then how the iteration will go. So you can see here that the iteration will go when we call function inside of a function. Function inside of a function. And what is the condition? The condition is this, which is else. What is this else? This else is that n is not equal to 1, and also n will be greater than 0. So that's the condition to do the iteration. This is the condition to do the iteration. Why this is the condition to do the iteration? Because if n is not both condition, then it will go to this else, and this else will have function call inside of function call. So it's mean it will be looping. Okay, so we have the initial, we have the condition to do the iteration. So this is the second parameter and this is the first parameter. And then what will happen, I mean that what condition to stop the looping. So in recursion, to stop the loop, you just need to return value without calling any function. So you can see that in this condition, else if n equal to 1, and this condition n less than or equal to 0, we don't have any function call. So this will be the stopping condition. This will be the stopping condition. If we don't have these two things, or maybe only one condition also, it's okay, then the loop will go infinity. Okay, so this is very important. This is for stopping the loop, stopping the recursion, and this is the recursion itself. Okay, and this also important because the counter is based on n, and n is equal to 5, and the stopping criteria, the stopping condition, if n is less than or equal to 0 and n equal to 1, it means that this 5 should go to 1 or 0 to stop the iteration. Therefore we just decrease the n one by one. Okay, that's the rule how to make a recursion. You have to remember that you have to have this condition to do the iteration, and then what is the stopping criteria, and you have to think how to deal with the counter. So the counter should go to the stopping criteria. Now I hope you can answer this quiz. Is there any another way to describe repetition rather than using for, while, and do while? Yes, by using recursion. And then what is the advantage of using recursion? The advantage of using recursion is that the program is simpler. We will see in the next example about this. And what is the disadvantage of using recursion? As you can see here, the disadvantage is that you need a lot of memory to do recursion, because when we call until 5 function call, then we have so many memory of n here. We have 5 memory of n, and then we have 5 memory for returning the value. So that's the disadvantage of using recursion. Okay, let us see the next video.